We will be discussing the problem in Pitel's book at page 161. Number 4.14. Calculate the force P that is required to hold the 120-pound roller at rest on the rough incline. First, let us identify the given and the required in the problem. Analyzing the diagram in the problem, we can see that if we wish to solve for force P in this problem, we should establish a moment equation at point A as a moment center, because the unknown normal force, or the frictional force, intersects in this point. If we used point A as a moment center, we wouldn't be needing to include the normal force, or the frictional force. Solving the moment equation that we can get from point A, we will get a value of P is equal to 35.9 pounds. We will be discussing the problem in Pitel's book at page 163. Number 4.20. The man is holding up the 35-kilogram ladder ABC by pushing perpendicular to the ladder. If the maximum force that the man can exert is 400 Newton, determine the smallest angle theta at which he can support the ladder. First, let us identify the given in the problem. As we can see in the problem, there are three unknown, in which they are two forces and one angle. Since there are two unknown forces, we can just use the moment equation to simplify our solution, since we only need the angle in the problem. If we are to solve for the angle, we are to use point A as the moment center. For us to be able to neglect the two unknown forces in our solution, we cannot use another point in this problem, since we only need to neglect the two unknown forces to be able to solve this problem more efficiently. As we can see, we can solve this step by step through algebra and trigonometry in order to solve for the angle, which is 39 degrees. We will be discussing the problem in Pitel's book at page 174. Number 4.40. The mechanism shown is a modified Geneva drive. A constant velocity input produces a varying velocity output with periods of dwell. The input to work is 120 Nm. For the position shown, compute the contact force at B and the magnitude of the reaction at A. Neglect the friction and the weights of the component. First, we must identify the given and the required in this problem. Then, we make the free body diagram of the problem. After making the free body diagram, let us examine the free body diagram. We have two kinds of equation we can always use to solve for a problem. It is either a force or a moment equation. As we can see, if ever we use the force equations, we will be having two equations, in which there will be no variable that has an unknown. So we can only solve this problem using the moment equation. In this video we will be using point A as the moment center. Thus, this expression is derived. As we can see at the expression, we can already solve for force B. Now that we already have the force B, we need to solve for force A. We can solve force A through the force equation. As we can see in the force equation, that force B and force A are equal, in which making them have the same value. We will be discussing the problem in Pitel's book at page 198, number 4.92. Compute the tension in the cable BD when a 165-pound man stands 5 feet off the ground, as shown. The weight of the stepladder and friction may be neglected. First, let us identify the given and the required in the problem. The problem stated that there is a 165-pound man in a ladder, and we are required to find the tension in the cable PD. Then, let us make the free body diagram. Let us examine the free body diagram. As we can see, we can only solve for the tension in cable CD if we divide the diagram. And since we have an unknown force, we are to solve them first. Examining the forces, we already solved them through the free body diagram that we can see. We can see in the free body diagram, we do not know the distance of the man at the x-axis in respect with point A or point E, so we are to establish a relationship so that we can solve for the distance of the man. As we can see, there is a right triangle that we can use. So let us use that triangle. First, let us make the bigger triangle, which has a longer leg of 7.5 feet and a shorter leg of 2 feet. Then let us make the similar triangle, which has a longer leg of 5 feet and a shorter leg of x, since we do not know its distance. We can either use the tangent or the cotangent of the angle for us to be able to solve for the relationship. In this video I used a tangent. In the relationship, the value of x will be 1.3 feet. Now that we know the distance of the man from point A or E, we can now use a moment equation. As we can see that we cannot solve this problem through force equation since we only have one force equation, which is respect with the y-axis. Now, let us use the moment equation. Like any problem, we always choose which moment center we are going to use. In this video, I used point E as the moment center, but we can also use point A and C, in which it will yield the same answer. You can also choose B or D. That would make the problem more complicated, since you'll be needing to solve for the distance of point B or D with respect to point A and E, and the simplest moment center would be A, since when we were able to solve for force B, we can already solve for the tension at cable CD without considering the force exerted by the weight of the man. Now let us establish the moment equation. We always use the convention counterclockwise positive, clockwise negative. After we get this equation we already solved for f sub a, we can already stop here and solve for the tension. We will not be solving for the tension yet. For us to fully understand that point A is the best choice of moment center. If we used point A, we won't be able to solve for f sub b, so let us solve for f sub b using force equation, since f sub a is already known. This will be our established force equation. Now solving the equation I'll be able to get this value for f sub b now. Let us solve for the tension. First, we need to divide the system, since the tension in the problem is an internal force. Cutting it perpendicular to point C, we get this free body diagram. Now, let's solve for the tension using the moment equation with respect to C, which will give us 36.7 pounds.